Oh my god.
Yo, I almost wasn't gonna make this video, but then I found out all I had in my wallet were Chuck E. Cheese coins. So now we're going to be building a homemade Hypercube in an attempt to save some money. But let me warn you guys, if you came to see a perfect build and a well-explained tutorial to follow along to, then you came in the wrong place. But if you wanted to see me miserably fail and possibly injure myself in an attempt to finish the project, then stay tuned. Alright, let's get started already. Alright? Whatever, let's get started. Alrighty, so to start off this circuit, we're going to obviously start off with a power source. Oh. Don't tell me this marker's dead. This marker's dead. Alright. First off, we're going to start off with our power source. This side is going to be positive, this side is going to be our negative. This side will be attached to ground, and this side will be attached to a switch. We're going to have an Arduino Nano, and we're going to have two potentiometers, one to control the hue, the other to control the brightness. We'll have both of these connect to our ground, go all the way over here to our positive. So now we're going to have an RGB strip. We have 3 pins here. This is our data pin, so this will be connecting to, like, let's just say digital output 1. And there we go. The secret behind the Infinity Cube is using one-way mirrors in all the interior faces of the cube. The mirrors are reflective on one side, but then the other side is transparent. It's the same thing used in those interrogation movie scenes. So basically you can exploit this to create infinite hallways of lights while still making it visible. But we're gonna need a prototype first, so let's get those materials. Okay, we need an RGB strip, potentiometer. Oh! Of course, we gotta get our switch. Can't forget our breadboard. Last but not least, our Arduino. So far so good. We got the lights to work, but currently the potentiometers adjust values a little bit too sensitively. Basically, the hue and the brightness are typically limited to values between 0 and 225. But currently the default analog values of our potentiometers bring out 0 to 1017. As we turn the potentiometer, it quickly rises past the 225 mark, like this. What we need is a function that will change this line into a linear line that won't exceed 225 as it reaches its maximum. Luckily, we could easily do this by using the map function, which remaps a number from one range to another. Not gonna lie, I just copied this one from the Arduino reference, but you get the point. Now if we re-upload our code and look at our serial monitor, it shows the potentiometer doesn't bring values out of range, which is pretty cool. Alrighty, so we finished the prototype, but now we could start working on our wooden frame that we're going to use for our final build. Shout out to my dad for cutting the wood, but now we gotta work on making the electronics more permanent. So how do we do that? We use a soldering iron. This thing is super useful and absolutely essential if you want to make circuits. It melts solder onto circuits, but lots of people get intimidated by it because they're afraid to get burned. Luckily, I haven't been burned by this thing for 3 years, and I don't think I'm gonna get burned anytime soon. I just had to jinx it, didn't I? I had to. I had to.
What?
Alright, let me calm down. Basically, if you're wondering what it felt like intense sting on contact with the soldering iron, and then after treating the burn, it felt like my finger was still burning the rest of the night while I was trying to go to sleep. So basically, I didn't get much sleep. Future me, just use the clips where I don't get burned. Got it? Alright, good. Alrighty, now let's test this bad boy. And it doesn't work. Crud. Okay, I'll be right back.
2,000 years later.
Okay, so the problem was that I plugged in the lights backwards. Rookie mistake, but I think it should work now. Phew, I almost thought I jinxed myself again. Alright, now what's the first thing you notice when you look at this mess? Wait, dang it, I spoiled it. The whole thing looks messy is what I'm trying to say. So how do we fix this? We're gonna use some cardboard. Okay, we have our finished cardboard box thingy. Basically, all the electronic components are now squished into this box, and it looks a lot cleaner. We got the battery pack in the bottom. We got our Arduino port in the back if we ever need to re-upload some code. We got our unofficial logo on the front because there's this big empty space and I didn't know what else to do with it. We have our on and off switch right here. We have our two potentiometers right here that will change the hue and brightness. Pretty good. Now all we gotta do is attach the LED strips to the frames, glue them together, and also attach the one-way mirrors. Shouldn't be too hard, right? Okay, so it turns out I only have enough LEDs to fill up one square. It looks pretty cool right now, but there are 5 more of these to fill. So if I have 16 LEDs per side, I need to multiply by 4 to get the total LEDs for a single panel. Then if I multiply that by 6 for 6 sides of the cube. Finally, if each LED is around 18 cents, I can multiply this by 0.18 to get the total cost. I'll show you. If I don't have enough money, I'm just gonna have to get some.
A few moments later.
In case you don't want to do this, drop whatever's in the bag now. I repeat, drop. Alright, so I finished gluing and wiring the frames, but Houston called and we have a problem. Even though the previous versions all worked, for some reason if we tried turning on the LEDs, it won't light up. This could mean 2 things on the top of my head. Either I messed up the code while trying to make the Arduino compatible with more LEDs, or I just wired something wrong. But I'll see you guys when the problem is fixed. It didn't matter though. After trying to fix this problem for weeks, I came to the conclusion that we just didn't have enough power to light up all the LEDs. Even if I decided to upgrade my power source, the max output voltage of the Arduino is only 5 volts, which is clearly not enough for 384 LEDs in my case. I apologize to the 11 viewers on this video for not finishing this project, but I hope you guys were able to learn something from my mistakes and I hope that you're able to learn something from my mistakes and that you didn't cringe too hard from watching this video. I don't take this as a complete failure though, because I did learn a lot from the experience and this video was also really fun making. Other than that, I hope you had a fun time watching and I'm out. Peace.